Alright, so let's continue more with logs. Let's remind ourselves some exponential properties. So, when you multiply, what do you do to those exponents? You add them. When you divide, you subtract them. When you have a power to a power, you multiply them. When you have a negative exponent, it is now a fraction to become a positive. And anything to the 0 is always 1. So connecting some of those properties, we can look at the inverse, that log. So when you see a log base and there is a multiplication, to separate it we can use addition, which makes sense because right here we go from multiplication and we add the exponents. Whereas the quotient rule, when we divide here, to separate them we can subtract. And when we have a power to a power, what can happen is we can plug that exponent in front and make a multiplication. So with these properties, what we're going to do is expand and condense. So keep in mind which one you're doing. Expand means that you're going to put everything into multiple log problems. Okay, so we're going to do this excuse me, by separating probably the division and multiplication first and then moving those exponents in front. So as you can see here, our A and B are multiplied by each other, which means between those two we're going to have an addition, and we have this division here, which means we're going to have a subtraction. So I'm going to write this as log A to the 4th plus log B minus log C to the 5th. Okay. Now, if we're expanding all the way, we have to put those exponents in front. So our final answer is going to be 4 log A plus log B stays the same minus 5 log C. And that's expanding. Alright, in B here, we have to do some rewriting before we can expand. So let's look at this as ln m to the 3rd n to the 1/2. Okay, there's a couple of things we can do with this. Now, exponent to exponent, remember, is we multiply them. So I'm going to multiply those out. So I get ln m, 3 times 1/2 is 3/2, and n, 1 times 1/2 is 1/2. Alright, now let's start expanding. So multiplication right here means what? It means addition. So I have ln m to the 3/2 plus ln n to the 1/2. And now we have to move those exponents down. So our final answer is 3/2 ln m plus 1/2 ln n. Alright, so this next one, because of course we're not just going to do the same problem over and over, there's going to be some tricks with it, okay? So we could see that the W and the H is multiplication, so we're going to add those, right? The A and the B are multiplication, so we're going to add those. The problem is we're subtracting all of the A and the B. Okay, so I'm actually going to do this the long way and then show you a short way after that. The other trick problem is this 2 right here. The thing is, the 2 is times the W is times the H. So the 2 also has its own log to it. Do not bring the 2W together. Well, I guess you could, but it's not expanding all the way out. So let me show you the expansion here. So we have log 2 plus log W 4. And this looks like kind of log base 2, so let me rewrite that as log 2. Sorry guys, this is what I get for using a pencil. Now I'm going to subtract all of the A and the B, so I want to show you what that looks like. So even though I'm going log A squared plus log B to the 5th, what am I going to do actually with that negative? I'm going to distribute it, so it becomes subtraction for both. And that makes sense because in the numerator we're having all addition, but in the denominator we're going to have all subtraction. Alright, so now I'm going to distribute that negative and I'm going to bring the exponents in front so we can get our final answer. Log 2 plus 4 log W minus 2 log A, and then distribute that negative out, so minus 5 log B. And that is our final answer. Let me circle these so we remember what the final answer is. Now be careful here, because if we can actually break that down more, let's break it down. But log base 10 of 2 is not really something we need to break down further. Alright, so let's see if we can deal with what our trick is. So in the numerator we have addition, in the denominator we're going to have subtraction. Okay guys, we're going to put it all together. Don't forget the base is not 10 here, it's 2. So we have to rewrite that base each time. So log base 2, I have to separate this. These are two different terms. So 4 plus log base 2 of x cubed. And then I'm just going to do subtraction with both of those because we learned in this problem we just distribute. So log base 2 y squared minus log base 2 z to the 4th. Okay, now let's bring the exponents in front for these three, but I want you to look at this really quickly. Log base 2 of 4. 2 to the what is 4? 2. So instead of rewriting this, this is actually the value of 2. Okay, this is the value of 2. So we're going to actually calculate that. And then we're going to bring those exponents in front. So 3 log base 2x minus 2 log base 2y minus 4 log base 2 of z. And circle that. So just as a reminder, when we expand, you know you are in your final answer when there are multiple logs. Each log only has one term, and the exponent is 1 because we moved that exponent out front. So see, each of these has one term to the first. One term to the first. And that's how you know you're all done. Now, if you have numbers, you want to see if you can calculate that to a whole number. And in example D, we did that. All right, let's go on to the Next one, we are going to condense. Alright, condensing means that we're going to make our answer into one log or one ln. Okay, the first thing is, think about going backwards from expanding, right? So the last step we did on expanding, like right down here, the last step we did was we put our exponents in front. So if we were condensing, we have to go backwards. So we're going to actually put those exponents back where they belong. So I have ln of x plus 1 minus ln of x minus 2 to the third. Okay, so we're going to put those exponents there first. Now, I see that it's a subtraction. And remember, what did subtraction mean? It meant division. So our final answer is 1 ln, because that was the idea, was to have 1 ln. And then it's going to be x plus 1, since it's minus, it's division, of x minus 2 cubed. Okay. So in B, first step, get the front coefficient back to the exponent. So we get log 3 plus log a to the fourth minus log b to the 2/3. Now remember, 2/3 is the cube root of b squared. I'm not going to be too picky right now about simplifying that into the right form, but keep in mind what it can look like, and I'll show you that at the very end of this example. Now, addition means that we're multiplication, and subtraction means that we're dividing. So the addition means that it's in the numerator, and the subtraction means it's in the denominator. The idea is just to have one log. That 3 and that a to the fourth are in the numerator because it's the addition, and in the denominator is that b to the 2/3. And we are done. I'm going to show you how to simplify that 2/3, but I'm not going to be picky about it in your practice work. So log 3a to the fourth all over, and again, it's the cube root of b squared. I'm going to put a parentheses around it, guys, because I want to remember that this log is right up front. Sorry for the sloppiness. Okay, wow, there's a lot of this here. So let's do our exponents first. So ln a to the fourth minus ln b to the third plus ln c to the seventh minus ln d plus 1 to the fifth. Now, let's just take the simpler route of reminding ourselves that addition goes in the numerator, subtraction goes in the denominator. Okay, so these subtraction ones go in the denominator. When condensing, we are going and breaking it down to 1 ln. So I'm not going to write any more ln's. A to the fourth is in the numerator because it's a positive or adding. C to the seventh is in the numerator because it's also an adding. And then the subtraction ones are in the denominator. And we are done. Let's do it again. So don't forget the log base 5 here. This is what most people forget in this example. So we have log base 5 of x to the third plus 2 log base 5 y to the second minus log base 5 to the z minus 1 to the 7th. So these two are in the numerator. This one's in the denominator because it's subtraction. Remember, we're condensing, so log base 5, we only have to put that once. X cubed goes in the numerator. Ooh, I see I made a mistake here because I rewrote the 2. I moved it, but I rewrote it. This is not supposed to be there, guys. Okay, so y squared is in the numerator, and z minus 1 to the 7th is in the denominator because it is subtraction. Alright, there are no coefficients up front in this, so we don't have to worry about exponents. Subtraction means what, guys? It means division. So I'm going to write log base 3. There's only going to be one of those. And now I have 108 divided by 4. Now I don't see any variables in there, so I'm going to see if I can actually reduce this more. Log base 3, well, 4 goes into 10 twice, leaving 2. And then 4 goes into 28 7 times. Can we reduce this even more? 3 to the what is 27. 3 to the what is 27. And I'm doing that like this, guys. 3 to the what is 27. Well, 3 to the third is 27. So our final answer is 3. Alright, now let's change some bases because we're going to solve by changing base. What I mean by that is many calculators cannot do logs of other bases. So what we need to keep in mind that if we have any base other than 10, we can change it by doing log x over log b. X is there and b is the base, okay? Knowing that b cannot be 1. Okay, it also goes the same way. We can change that log into ln's. So, on your calculator, first ln 7. ln's we can do. ln is right here. We're going to go ln 7. And I want you guys to round up to the third decimal place. This gets us getting used to higher level math, which usually goes out to the third decimal place. So it's 1.946. Okay, so basic ln's we can do in our calculator. There's a button for it. Just like log. Remember, when the base isn't there, it's automatically log base 10. And then there's also a button on our calculator. So log of 0.15. And that gives us negative, approximately, because we're rounding, 0.824. Alright, here we have different bases, so we have to change that. So if we use this, log x. So I do log of 17 all over log of the base, which is log of 4. So let's put that in our calculator. Log of 17 divided by log of 4. And we get approximately 2.044. Let's do it again. Log, and we would do log of 26 all over log of 52. And do that calculation in there. Make sure your parentheses are in the correct spots. And we get approximately 0.825. Now, guys, make sure you show your work, and especially if you're using the calculator, I want to see this step. I want to see what you're plugging into the calculator. These I understand that you'll be able just to plug them in and that's it. But these I want to see your changing of the base before you do your calculations. Alright, practice condensing, expanding, and changing the base. Just remember which one you're doing first.